All right, continuing on with the study guide. Now we're going to talk about color. So, how does Roy G. Biv relate to the visible light spectrum? Remember, that is a way for us to get the order of the colors. Okay, so visible light is all made up of colors that are different wavelength and frequency waves. Okay, it's just like the main electromagnetic spectrum, it's kind of like a subset of it in the middle. Remember, it's always in the middle, okay, of the whole electromagnetic spectrum. So Roy G. Biv is red, orange, yellow, green, blue, indigo, violet. So that's the order of the colors. Now, in terms of features, okay, red has the longest wavelength, and then it trends down to violet having the shortest. Remember, wavelength and frequency slash energy or inverse, so that means that red also has the lowest frequency and energy. So it's kind of like the radio wave of the visible spectrum. And then violet has the highest frequency and energy. So it's kind of like the gamma ray of visible spectrum. Okay. So Roy G. Biv gives us the order of the colors in the visible spectrum. In terms of features of the light wave, how is red different from violet? I kind of already talked about that. Okay, red has a longer wavelength and a lower frequency and energy value than violet. Violet has a shorter wavelength and a higher frequency and energy. Okay. How do we see white and black? All right, so this has to do with absorption and reflection. So when we see something, we've got light coming in. Okay, so let's say we're looking at I don't know what's something I can pick really quickly. Okay, let's say we're looking at an apple. This is a terrible drawing, but that's okay. You all know I'm a terrible artist. So let's say we're looking at an apple. All this light's coming into the apple. The apple's going to absorb some of these wavelengths and reflect back. Okay. Ooh, and actually, that's what we're going to talk about down here in just a minute. Okay. If we're looking at something that reflects all of the colors back to us, then it's going to appear to us as white. So, like this paper, okay, that I'm writing on. So, if all the wavelengths of light are reflected, I can't write. If all of them are reflected, we see white. Remember, white light is a combination of all of these colors here. Okay. So if we're seeing something that's white, everything's reflecting back. If we're seeing something that's black, that's if all the wavelengths are absorbed and none are reflected. So black is, I don't know, it's almost like an absence of color. I guess it means that all of the wavelengths are being absorbed by this item and none are being reflected back. I'm trying to find something. Here's this calculator case, okay, and it's black. So all of the wavelengths of light are being absorbed by this material and none of them are reflecting back to us, okay, versus this paper, they're all being reflected back to us. So we see white, okay. So what does a prism do? A prism can separate that white light into the spectrum of colors. Okay. And we watched a video on this. So it separates white, which is all the wavelengths, into the individual color wavelengths. Okay. So we have this incoming beam of white light, and then it gets split by this prism into all the different colors. Why do they bend differently? That's due to their wavelength. So like red bends the least. It has the longest wavelength. Okay. And then violet is going to bend the most because it's got the shortest wavelength. Okay, so the amount of bending depends on the wavelength of the light. Red bends the least, violet bends the most, and then everybody else is in between. And you can see this bend, this is kind of slighter here for red than it is for violet. Violet's more pronounced in terms of bending. Okay, and then here's what's happening in the following image of a red apple. Why do we see the apple as red? I kind of talked about this already. So we're seeing all wavelengths of color are coming in here, okay, hitting the apple. Okay, and then what's happening in terms of the apple is it's absorbing up wavelengths other than the red. Okay, so the apple absorbs all wavelengths except red, and then red is reflected back to our eye. And in most objects, like you're seeing a number of different wavelengths reflected back. I mean, when we look at just about any object, it's not one single color. There are some, I guess, some things that are, but a lot of objects, they're going to be a combination of some wavelengths that get absorbed and some that get reflected. It's that absorption and reflection that gives us the color that we see. Okay, so in the case of the red, the apple's absorbing all these other, green and blue and yellow and all these other colors. It's absorbing those and it's just reflecting back the red color. And that's why we see the apple as red. Okay. All right, we got one more page. I think I'll make that the last video just so this one's not too long.